Hello, brewers, and welcome to this technical talk about the SafBrew BR8. The content of this presentation will be a quick introduction about the SafBrew BR8 and exactly what is behind this name, the objective and characteristics of the R&D that we run to obtain this product, and then the aromatic compounds production with the SafBrew BR8, an applicative study with a bottle conditioning, and then some key learnings. So first, in the introduction, what is a Brettanomyces? So SafBrew BR8, BR8 stands for Brettanomyces, as a way to remember what is behind this special microorganism. So Brettanomyces is a yeast, a wild yeast, that has been found already in beer in the early 20th century. And Brettanomyces stands for Brittany, England, and myces for fungus. So it was found in some beers produced centuries ago. But today it is still used in the brewing industry and also other beverage products, such as, for example, kombucha. Naturally, you can find some Brettanomyces on some fruit peels, on tea, on olives. And then coming back to the beer world, we can find Brettanomyces being used in the production of wild ale and very traditionally also Belgian lambic and gueuze. So the Brettanomyces in the processing of those beers, Brettanomyces are found in the air, in the atmosphere, and they are naturally inoculated into the wort in those big cool ships, as we have seen on the previous slides, so that the microorganism can inoculate the wort and then later on be used in the process during the fermentation. Brettanomyces have a big impact on the profile of the beer, on the organoleptic profile. They have the ability to produce phenolic notes, esters, and also aroma. Today, we can find Brettanomyces more and more used in the production of novel kind of flavors for your beer, such as in a wild ale. So you could produce just a wild ale or a wild farmhouse with the Brettanomyces, just to add a little bit more funky notes, a little bit more of those very interesting phenols that the bread is capable of producing. But that's not it. We will see later in this presentation that the Brettanomyces is also able to produce two other main flavors. So if we were to compare the Brettanomyces versus the classic Saccharomyces cerevisiae or Saccharomyces pastorianus that you're using in your beer, we can see that in terms of sugar consumption, the Brettanomyces has the ability to consume the maltodextrose, which is also the case of the pastorianus, so lager yeast, and also the case of only a few Saccharomyces cerevisiae. Then in terms of flavor production, what is very interesting with the Brettanomyces is that it has the ability to produce volatile phenols, and those phenols will impact the beer, will give some interesting phenolic notes, so smoky, spicy, and also barnyard and farmyard kind of flavors. Then coming to the objective and characteristics. So what were the objective from Fermentis to release the BR8 on the market, and what kind of microorganism we were looking for? We have everything summarized here on this slide. So we wanted a Brettanomyces, of course, but then we wanted a Brettanomyces that was already used, widely used in the brewing industry, and this is why we chose the Brettanomyces bruxellensis. So as the name says, bruxellensis relates to the origin in Brussels, where we have very high production of lambic and gueuze beer. And then on the fermentation profile and sugar assimilation, what is very interesting with the Brettanomyces bruxellensis is that it is not consuming the dextrins. So that it's really helpful and easier for you as a brewer to use this microorganism, because you can have more consistency in the consumption of sugars. It's much easier if you have a microorganism that is not touching the dextrins, so that you can avoid having over carbonation and over consumption of sugars in your beer. We also wanted this strain to be suitable for bottle and cask fermentation. So this is why the BR8 is robust to re-fermentation conditions. When you use a yeast in re-fermentation, you have already CO2, you have already alcohol, you have a lower pH. The Brettanomyces bruxellensis, has all this tolerance, so that it can ferment very easily in a re-fermentation. And then in terms of flavor, it would produce funky notes such as horsey, farm, animal, leather, but also smoky notes to the beer. In terms of specifications, as usual, very good purity in this strain, as you can see on the right-hand side. And then in terms of viable cells, we have 5 billion CFU, so colony forming unit per gram. So 5 billion cells in 1 gram of the SafBrew BR8. In terms of aromatic compounds production, this is where it gets super interesting. As I mentioned already, of course, what we're looking for in the Brettanomyces is the puff character, so the phenolic production. You can find this already in Saccharomyces cerevisiae, as you see on the top of the slide. The first microorganism is the Saccharomyces cerevisiae, and so puff positive yeast have the ability to produce 4-vinyl guaiacol and 4-vinyl phenol. Those compounds are producing notes such as clove, dentist, smoky. On the other hand, the Brettanomyces is able to produce the ethyl guaiacol, 4-EG, and the ethyl phenol, the 4-EP, which have different notes, different perception of flavor in the beer, such as horse, animal, leathery, and smoky. And how does it work in brewing a wort? So if you start with your brewing wort, what you have in your wort is some precursor of the phenolic compounds, such as 4-VG and 4-VP. So this is coming from ferulic acid and coumaric acid, which you have in your malt. And thanks to an enzyme, the puff positive Saccharomyces cerevisiae have the ability to convert those ferulic acid and coumaric acid into vinyl guaiacol and vinyl phenol. Only the Brettanomyces has the ability to go one step further and then use a reductase to reduce the vinyl into ethyl, leading to 4-ethyl guaiacol and 4-ethyl phenols, which have, as we have seen on the previous slide, different flavors perception in the beer. Then the second thing very interesting about the Brettanomyces in comparison with the Saccharomyces cerevisiae, this is about the ester production. On the left-hand side, you have an example of a few esters produced by the Saccharomyces cerevisiae, and we see mainly the production of acetate esters, such as isomyl acetate, banana, which you have, for example, in Weiss beer, and also phenylethyl acetate, so the rose flavor. So those are acetate esters, mainly produced in the metabolism of Saccharomyces cerevisiae. On the right-hand side, we have the Brettanomyces and its ability to produce ethyl esters, such as ethyl acetate, ethyl hexanoate, red apple, ethyl octanoate, tropical pineapple, and also the ability for the Brettanomyces to convert to esterified fatty acid chains into specific esters, which have a very interesting flavor impact in the beer. And then the third point about the aromatic compound production with the Brettanomyces is that the SafBrew BR8 has a beta glucosidase inside the cell, so that you are able to release terpenes in your beer from, for example, hop or certain fruits. So you have inside those, you have precursor of terpenes that are linked with glucose molecules. And it's only when you have a beta glucosidase cutting this glucose molecule from the terpene that you can release the terpene and release their flavor potential. As you can see on the right-hand side, a few examples of flowery notes, rose notes. So those are a few of the terpenes you can release with the Brettanomyces. And then coming to the applicative study. So we have, after selecting the Brettanomyces bruxellensis, we have been using it in a real application, and the application that we have chosen is the bottle conditioning. So on the left-hand side, you have the parameters of the beer we have used. So it's a beer that was already fermented, already went through primary fermentation, ended up at 6.3% ABV from a puff negative yeast. It had already 3 grams per liter of CO2. And then we used rehydrated samples of BR8 that we added at a rate of 5 grams per hectoliters, plus 10 grams of liter of sugar. And then we kept those beer for bottle conditioning during 1 month and 3 months at 24 degrees Celsius. And what are the interesting outcomes that we have seen? So this is coming up on the next slide. We are looking here at the analytical measurement of the 4VP, 4VG, so the vinyl, phenol, and vinyl glycol, and then the 4EP and 4EG. And we're looking at other units. So it means that anything above 1 is above the threshold, and so it's something that you will perceive in the beer. And very interestingly, with the Brettanomyces, you don't have any more VP and VG as you would have with a puff-positive Saccharomyces cerevisiae. The Brettanomyces has converted everything into ethyl phenol and ethyl glycol. On the right-hand side, we are correlating those analytical results with the sensory analysis from our panel. And we asked them to give a score between 0 and 1 about the Brett fingerprint, the Brett footprint that they were able to perceive in the beer. So of course they have been trained beforehand on the 4EP, 4EG, on those very specific note of the Brettanomyces, and then they had to give a score. And we see that after 1 month in dark brown, they already gave a very high score of the Brett footprint. And then if you wait 3 months of bottle conditioning, you see that the beer is still evolving. And on the left-hand side, we see that we have more of the 4EG. And then on the right-hand side, we see that the score is very close to 1. So throughout all the sample, after 3 months, they have a very much higher footprint of the Brettanomyces. If we look more specifically at the analytical results after 1 month and 3 months. So first, if we focus on 1 month, we see that the 4EG has much higher concentration in the beer in comparison with the 4EP. And then if you wait 3 months, the 4EP is not evolving much, but you have higher amount of 4EG that is produced. So giving more of the funky barnyard and horsey notes to the beer. Already significant footprint after 1 month, significant concentration. And if you wait 3 months, you have even more of the 4EG, sorry. And then here we're looking at the sensory analysis again. So from our panel, looking at all the different samples that they were given. And then the C here on the very left is the control. So this was fermented with the SAF Ale F2, which is our bottle conditioning yeast. And then if you use the Brettanomyces, of course, you have significant notes of smoky pharma that are perceived. and significant notes of horsey. But if we look at 1 month, we see that there's not a very strong consistency. Of course, the bread footprint is very much present, as you can see with the curve and the score given to the beer. But if you were to wait 3 months instead of 1 month's bottle conditioning, then you see that the bread footprint is very much more consistent in the beer and almost given a score of 1 for all the samples. So about the key learnings of this SafBrew BR8. SafBrew BR8 is a Brettanomyces bruxellensis. If you want to use it in bottle conditioning, as it is traditionally used, so you can either use it in a cask, in a barrel, or also in a bottle. So for this, use the SafBrew BR8 by rehydrating it in 10 times its weight in sterile water. The rehydration temperature should be between 25 and 29 degrees Celsius. Then the dosage rate of the SafBrew BR8 is between 5 and 10 grams per hectoliters, and the refermentation temperature between 15 and 25 degrees Celsius. So if you want to really increase the speed of the process, I would suggest you to go for 10 grams per hectoliters of dosage, and also a refermentation temperature of 25 degrees Celsius. Like this, you have a high population of bread from the beginning, also a higher refermentation temperature for higher enzymatic activity, and then a much faster footprint, much faster funky notes developed in your beer. In terms of phenol production, of course, we have seen in the previous slides, you can expect high concentration of 4-EP and even higher of 4-EG, imparting for horsey and funky character to your beer. In terms of storage, if you intend to store the SafBrew BR8 for a long period of time, so longer than 6 months, then it is suggested to keep it at 4 degrees Celsius, and like this you can achieve 2 years of shelf life. If you were to use also the SafBrew BR8 in primary fermentation, this is also something possible. And for this, we suggest you to use the SafBrew BR8 in co-inoculation with a Saccharomyces cerevisiae that is maltodextrin positive, so that you can have much more consistency in the consumption of sugar and make sure that you don't leave any residual sugar for the Brettanomyces and that you avoid overcarbonation of your beer. So in terms of dosage, if you're going for the primary fermentation and co-inoculation, we suggest 50 grams per hectoliters of your Saccharomyces cerevisiae, maltodextrin positive, and 50 grams per hectoliters of the Brettanomyces bruxellensis. And you will see, you can expect to have already some funky notes very early in your fermentation because of the higher temperature, the higher amount of population of Brettanomyces. You can expect a footprint of bread after 1 week. And as soon as you reach the level that you like, then you can keep going for the rest of your process and cool crush your beer. And then keep going for the rest of the process until bottling and already having the funky notes from the primary fermentation. So 2 ways to use it: primary fermentation or bottle conditioning. And then a few questions that we often have is about the risk of cross-contamination. So be aware that the SafBrew BR8 has a very low pulverulence. So if you open the pack, you don't have to be worried about seeing the BR8 going all around the brewery. And when using it in a fermenter, we have studied the sensitivity of the SafBrew BR8, and it is much more sensitive than a Saccharomyces cerevisiae to temperature. So if you have already a very efficient CIP in place in your brewery, a CIP able to kill the Saccharomyces cerevisiae, will be necessarily also very efficient against the Brettanomyces bruxellensis because of its higher sensitivity towards temperatures and chemicals. But if you want to play it very safe, you can either increase the concentration of your chemical or the contact time or the temperature. Like this, you improve the efficiency of your CIP. That's it for the SafBrew BR8. I hope you enjoyed it, and I'm looking forward to more wild beers coming from your breweries. Thank you for your attention, and see you next time. Bye.